Hi everyone. So this is another day in the lab, just to carry us through some lab work. We want to observe the color changes in different glass samples. Of course, the same composition but melted at different temperatures. So this is 700 degrees Celsius. Let us see what happens. Noting that this glass composition has sodium carbonate, has calcium carbonate, has magnesium carbonate, has silica, has aluminum hydroxide, has iron 3, has potassium carbonates. Yeah, I think these are the basic ones. So let us look at what happens. You could see that at this 700 degrees Celsius, I'm just pouring directly from the tiny crucible into the tiny bag, which means you see the color? No physical melting has really taken place. You see how kind of, I don't know what you can call that color, maybe pinkish. That's at 700. Then at 800, let us see what happens at 800 degrees Celsius. You see, I had to just heat it up a bit under to shaking the sample inside, but it is still powdery. If you remember that calcium carbonate decomposes at around 784 degrees Celsius. So you could expect that at 800 decomposition would have taken place and or rather started. So you expect that there will be release of calcium oxide and CO2 will be released out of the crucible. So you see the two colors. One is really looking lighter, the one at 800 compared to the one at 700. So this is the third one, the one I melted at 900 degrees Celsius. You see at this point, oh, it's just like solid. So something significant has really happened, because at 900 degrees Celsius, while we expect further decomposition, you also expect maybe silica and aluminum to begin to form an initial network and bringing in all the oxides that would have been formed. So at this point, this network forms the basic glass matrix, and there is, you see the three colors. Ooh, you see that? Let me rearrange them for you to make good comparison. You see 700, 800, and 900 being the brightest. And of course, at this point, bubble formation could continue, and CO2 will continue to leave the crucible. And of course, we expect the color change. You see the next one melted at 1000. Of course, while temperature increases, and viscosity should reduce, and meaning bubbles should leave the surface of the melt more easily. That is what you're seeing. But I want us to pay attention to why the color is like changing from what we saw initially, like very pinky, to this one that is looking lighter. And of course, we'll keep observing it till 1200 degrees Celsius. If you have anything you think that would have caused that, having noted the composition and know a bit of chemistry, you could just share with us. You see that? That's really interesting. And so we are going into after 1000. We shall look at, we see this for 8, 7, 8, 9, 1000. You see, yeah, you should see a lot of transcendence in color. And so we shall be looking at 1100 degrees Celsius now. Of course, at 1100 degrees Celsius, you should expect more melt homogenization. Expect that the components will mix more uniformly. You see that? Of course, bubbles will continue to rise, but more evenly distributed. Melt viscosity will continue to decrease. Of course, this will allow trapped gases to escape more readily. You see that? So that is the one melted at 1100 degrees Celsius you want to see now. And of course, it really looks more like something we intend is being formed. But yeah, you could see that pore spaces. That is the space is occupied by the gases, and then while they try to escape, you see that formed in that manner. Yeah, not really a lot of science we want to discuss, just a fun of being in the lab and looking at internal things that happen before we see our window glasses, before we see the glass cups we use in the kitchen, or glass bottles we used to take our beers and other drinks. We used to do our packaging. Like, this is the processes they undergo, but this is just the lab scale. You see that? Yeah, 1100 and 1000. You should still see. And then I add 900, and then I add 800. Oh, and then I add 700. Oh, you see the color changes. Can you imagine what has happened, considering the things that are present? Anyway, just to keep our day thinking and admiring science. So this is at 1200 degrees Celsius. Wow, like really looks glassy. Wow, you see that beautiful thing? So at 1200, of course, you should expect kind of full melting, but that doesn't mean the melting temperature of silica has been reached, but because there is flux and from formation of eutectics, you could expect a kind of full melting at this time, but not full fining. So if you want the bubbles and you really need a very clear glass, you should let it stay longer in the furnace. But at this point, a lot of redox balances, a lot of bubble removal would have taken place. So I just milled it and I get them ready for further experimentation, just to say cheers to what we do, cheers to my day-to-day work, cheers to science, cheers to research, cheers to experimentation, and trying to bring something new into the glass industry. I hope you appreciate this. I hope you adore this. I hope this inspires someone to think of researching, because that is what makes technology what it is, research and development. So this is me in the lab looking at different glass samples and comparing what happens, just observing and seeing, and ready to carry out further analysis. Cheers, Kai. Stay well, ask questions, seek clarifications, and if you have any inputs, I am happy and open to see that and to share with you. If you're working in the same field and you think we can collaborate, let's get at the comment section and keep making our world better. I have a target on this, and we shall be seeing that while we go on. Cheers and bye.